Today we are going to present our paired assignment for STA256. Here are the question 1. We can see there are two machines with unknown standard deviation. The question asks to construct a confidence interval for difference between two means. First, we must find important information like sample size, X bar, and standard deviation. To find the standard deviation, we must use pool estimator formula to find the S. Using theorem 5, we can eventually gain the difference between two means. And next, we must draw a graph to illustrate the equation that we get. So here is the graph after the illustration made. For the next question, find the 95% confidence, and after the calculation being calculated, we conclude that 95% confident that the difference of the two means are between negative 0.0163 and 0.0363. And here is the graph from the question and the answer given. For the third Roman, the conclusion is since 0 is included in the interval, we can conclude that both machines fill up glass bottles with the same net volume because they are both insignificant because they are 0. For question B, we know that the variance is 100 but the mean is unknown, so we must find the n. To find n, we must use this formula, z is equal y bar minus mu divided by sigma over square root of n. After being calculated, we can see here that the n is 15.9201, which is approximate to the 16. Next, find a 90% confidence interval for mu if the sample yield equal to 100. So as we know, sigma square is equal to 100, so sigma is 10. After that, we concluded that we are 90% confident that the mu is between 95.9 and 104.1.
And now we move into question 2, which says that x1, x2, until x of n are a random sample from this distribution, which is essentially just the exponential of lambda. Now, what we have to do now is find the sampling frame distribution of W. This part here is essentially unimportant, but what we must understand here is that x bar here is subject to the central limit theorem, which says that x bar must be distributed by the normal distribution. So what we do is we just copy in those values for mu and for variance over here. So once we know that, we will be able to find that x bar must be normal distribution with lambda and lambda squared over n. So once we work through that math, we will end up with W is chi-squared with 2n degrees of freedom. And now we move on to question B, which says that which now says that we have to construct the confidence interval for lambda. What we don't know is what the base distribution says, but we know that W must be chi-squared of 2n, and that W must be equal to 2 over lambda times n of x bar. So if we know the distribution and the definition, we can substitute that into our expression. So once we go through all that, we will be able to end up with an expression like this. Just making sure that when you invert, you are flipping the direction of the comparison symbol so that you will end up with a valid result after this. And now we move on to question C, which is essentially a plug in the values question. So what we do is you plug in the values into the confidence interval you just found. So once you are done, you would end up with the interpretation that the 90% confidence interval for lambda, where n is equal to 10 and x bar is equal to 90, is 5.731 and 16.5883.